They are clever.
Okay, so this 8-mark question...
Mummy, why did you say out?
It's quite a big one. You need about 3 or 4 minutes of thinking, of planning about how you're going to do your question. It'll probably take another, I think, almost 10 minutes to get it written, right? So it's 8 marks, so you've got plenty of time to get it done. So the first thing I see here is I notice that it's a manned space flight. Okay. So let me just get the right colours going here. It's a manned space flight. Okay, and then there's 2 things to mainly focus on. Changes in gravitational energy. Okay. Changes in gravitational energy. Let's get some good colour here. There we go. Okay, and then the second part of it is protecting the space vehicle from charged particles from the sun. Okay. Alright, so the first thing to think about is the changes in gravitational energy. This is how I think about the first dot point. I think about Earth. Okay. I think about Mars. And I think about the journey that the spaceship will have to take to get from Earth to Mars and what the changes in potential energy are. Now, it says gravitational energy, but gravitational energy and gravitational potential energy, they're intrinsically related. And then if I think about my spacecraft, I think my spacecraft is going to make some journey, right? And within that journey, there's going to be some considerations. Now, I've just done the trip from Earth to Mars. You can also, in your answer, think about the trip back from Mars to Earth and what the ramifications of that are. So here's what I'm thinking. There's a few stages to the flight. So for 8 marks, okay, we've got to think about these stages of flight. So the thing to think about is the launch from Earth. When we're launching from Earth, how much energy is used by the rocket and the rocket fuel to overcome the gravitational energy. So what's happening is, as we increase our kinetic energy and we're getting further away from the Earth, we're increasing our potential energy as well. So we've got to make this flight. We might go into orbit around Earth, or we might just launch straight away. Okay, I've drawn an orbit there, but let's think about what's happening. Maybe that's not the best picture. Maybe it should have just gone straight around to Mars. The thing to remember too is that there's some point here where the gravitational field of Mars overtakes the gravitational field of Earth. So the idea is we're going to have to use up fuel and resources to escape Earth's gravitational field. And while we're doing that, we're increasing the potential with relation to Earth, but we're also increasing our velocity. Okay, so that potential energy is being converted into kinetic energy. And the other thing to think about too is that once we actually have crossed over this invisible gravitational field, if you like, where the field of Mars becomes dominant, then what's going to happen is the rocket now is going to accelerate into Mars because of the gravitational field of Mars. So that potential energy is going to be converted into kinetic energy. So there's some real problems about getting the manned spacecraft to actually land on Mars. Now, because it's manned, there's a few things we can talk about. You can think about what are the forces on the astronauts when we decelerate this spacecraft to land on Mars. Okay, and that's one of the problems you have to think about. You'll also have to think about what are some of the problems related with high-speed travel, being in a weightless environment if you stay in orbit around Mars. So I think all the things I've kind of mentioned, I think they'll add up to about 5 marks worth. Okay, so things to think about are the whole journey and every step of the journey. Okay, when you're leaving Earth, okay, when we're leaving Earth, when we're leaving Earth, okay, when we're maybe in orbit around Earth, when we fire our rockets to overcome gravitational field of the Earth, when we actually go into the gravitational field of Mars, and then how do we actually slow that rocket down so that we can actually land safely. And on every part of that journey, there's kind of 4 steps there. Okay, launch, escaping Earth's field, there's potential energy, velocity, things that happen, gravitational field decreases, then it increases with respect to Mars, and what happens is we accelerate, so we're getting faster, potential energy is dropping, but our velocity is still increasing, then what the problems are to actually slow that rocket down, what ramifications that has, because if we have too many Gs, the humans will black out. If we spend too much time in a weightless environment, then the astronauts will undergo the effects of weightlessness. Okay, so I'll stop there to digest that. Okay, now the second part of it is protecting the space vehicle, okay, from high-speed electrically charged particles. So if we think about these things, this goes back to the Year 11 course. You can probably remember some of the things we did about the solar wind. So we've got electrons, neutrons. So some of the things that we can do to the spacecraft is we can have the spacecraft surrounded by an electric field. We could have the spacecraft surrounded by a magnetic field to try and deflect these charged particles that come from the sun or the solar wind. Other things we can do is we can use things like foil or gold foil to deflect some of these particles and also help keep the temperature down so that when the craft is in full view of the sun, the heat is not too high, okay? So there's some of the things we could do there. So protecting the space vehicle from the sun, that's kind of the second part. And I think those things, electric field, a magnetic field, and maybe using some sort of tin foil type material, that will probably give you 2 marks, okay? So we got 5 marks really for going through in a coherent, logical fashion all the potential energies, gravitational energies, and velocity ramifications of leaving the Earth and going to Mars, and what that does to the people inside. And then you've got 2 marks there for protecting the space vehicle, either using electric field or magnetic field to deflect positive and negative charges. Okay, and then the final mark really is just for a logical, coherent answer which pieces together everything in a logical fashion, and also you're trying to communicate to the examiner that you have extensive knowledge of the physics principles involved in a mission of getting a rocket from the Earth to Mars. Okay, so that's all I'll say about that. 7 minutes is enough, and I think you could easily spend 6 or 7 minutes writing this answer. I've probably overdone it. I've tried to do it nice and slow, but in an exam you could probably do this thinking through in about half the time, set up a little plan and then go for it, okay? Now I also recommend that you go to the Board of Studies website and check their sample answer for this, because it's very good. It's much better than the sample answer in the book, in the past paper book. Alright, so I'm going to upload this now and then I'll do the other 2 questions for you.